Is my screen can be seen now?
Yes, sir.
Yes,
Yes,
it is
sir.
visible.
Okay. Now, in the last semester, what you learned? Orthographic. Orthographic projection. Anything else? Anything else? Am I audible now? मेरी आवाज? Hello. Unless you answer, I cannot proceed further.
Yes, sir.
So, ऑर्थोग्राफिक के अलावा और क्या पढ़ा आपने और क्या सीखा? Give me the name of the topics only. Development of surfaces. Okay. Development of surfaces. Anything else? Projection of lines. Okay. Projection of lines. Okay. Anything else? Projection of points. Projection of solids. Okay. ठीक है. So the meaning is that we learned. Just a minute. We learned mainly projection. Am I right?
Yes, sir.
Yes. Okay. तो हमने projection सीखा है. So do you know what is projection? So let us say आपने देखा होगा. Let us say okay, I'll draw one solid. What is this looks like? ये कैसे दिखता है? How it looks like? Or how it looks like this? ये कैसे दिखता है? Can you imagine this object? How it looks like? Or how it looks like this? ये object कैसे दिखता है? ये कैसे दिखता है? What are these solids? Name of these solids?
First one cube, second one cuboid, third one cone.
Cone. Okay. So these are the regular solids, right? So we can see this as the 2D or 3D?
3D.
3D. So whether it is A, and if I draw a line is this and the point is this. So line point is a entity or it is an entity which is a dimensionless entity. Point, if I join 2 points, we'll get a line segment. And if I join, let us say 4 lines together or 3 lines together, this is called as a plane. This is basically a point. This is a line and this is a plane. So point is a dimensionless entity. And if I join 2 points together, it gives a line. And if I join minimum 3 lines together, it gives the plane. If I join planes, we'll get the solid like this, right? So if I draw the projection of either point, either line, or either plane, or either solid on a plain paper, a 2D paper, this is a plane, this is a 2D paper. So if I draw the projection of these lines or planes or the points or the solids on this 2D paper, that is called as projection. Correct, everyone? What is projection?
Yes,
Projection is nothing but it is image of an object or entity. It may be a point, it may be a line, or it may be a plane, or it may be a, what we can say, a solid on 2D paper, that is called as projection. Now this projection, this particular projection is classified as, anybody knows? This projection is classified as orthographic projection and isometric projection. Clear, everyone? The projection is classified as orthographic and isometric. So you learned orthographic projection. What is orthographic projection? Anybody knows what is orthographic projection? पता है किसी को? Yes or no? What is orthographic projection? What I assume? Nothing? Don't know anything about the orthographic projection? Abhishek Kumar, please answer the question. Abhishek Kumar. Are you there? If you're not able to answer, मैं पक्का आपको मीटिंग से रिमूव करूंगा, or you will be marked absent. Abhishek Kumar is there?
Yes, sir. Present, sir.
Okay. If you are the present, tell me what is orthographic projection? Sahil Jagtap is there? Sahil Jagtap?
Yes, sir.
What is this orthographic projection?
It's a method of projection using parallel lines.
Parallel lines. Okay. What is isometric projection?
We
So
have
basically,
not taught
okay,
isometric.
not taught. Okay, ठीक है. So basically, we must know there are different type of projection. It may be orthographic projection or isometric projection, but we must know how we define orthographic projection and how we define isometric projection. Now just concentrate on this word ortho. तो ऑर्थो हमने सुना है, कहाँ पे सुना है? मेडिकल फील्ड में. What is ortho? It is related with the bone, but it is not related with the drawing. Okay, so ortho in mathematics we learned. Orthogonal means what? Orthogonal. In orthogonal, in 12th standard we learned. What is orthogonal?
Perpendicular.
Perpendicular. Very good. So orthogonal stands for perpendicular. Now the question, you just forget about this isometric. Isometric हम बाद में देखेंगे. So in orthographic projection, the ortho stands for perpendicular. Now the question arises, what is perpendicular with whom? What with whom? कौन किसके साथ perpendicular? So that's why it is called as, somebody has told me that it is parallel lines, but we are calling this is perpendicular. Now the question arises, who is perpendicular with whom? That's why we are calling this as, it is a orthographic projection. Now let us say you can take any solid. Let us say you can take any solid. Let us say I'm drawing a cube. Okay. Now this cube has how many faces? Total faces. How many faces this cube has?
3.
Cube को कितने faces होते हैं?
6.
6.
Okay, very good. 6 faces. Now let us say the observer is here. और पहले projection में हमको पता है the projection is nothing but to get a projection we required a light source, an object, and we required a plane of projection so that we can apply the light here and I'll get some projection here. So we required a light source, an object, and plane of projection. Now, if I just take example that you are just walking on the road on a daytime and you will get the shadow of yourself on the road. That is also called as a projection, right? Now, if I take any solid and if I keep this solid in a space at any orientation, you will get the projection. Okay, that is called as a projection. But for simplicity, this is classified into two types. One is orthographic projection, second one is isometric projection. Now the question arises, what is orthographic projection or what is orthogonal? Now, let us say you are the observer. Now we are replacing this light source by observer. Instead of light source, we are taking observer. We are keeping this as object and we are putting a screen here. Let's say we are putting a screen here or a plane here. Now, if you just observe or look from this direction, he'll get some image and he can project it here. Now, suppose out of this, right now we can see only three faces or three dimension. That's why this is called as a 3D. Now, out of these three faces, I want only one face. I want to see only one face. When it is possible, I want to see only one face of this surface. When it is possible, suppose out of these 6 faces, I want to see only one face. When it is possible?
Top view.
It is possible when अगर मैंने उस particular plane को अगर मुझे surface को अगर देखना है, okay, I will show you something interesting to you. Okay, yes. जब तक ये इनिशियलाइज होता है तो हम देखेंगे कि हम कब 2D और कब हम 3D देख सकते हैं. The name of the particular software is Creo Parametry. Maybe you have heard some that the 3D modeling softwares are there, and we'll see कि ये जो मैंने अभी ड्रॉ किया वो कैसे दिखता है. So we'll create a construct a particular cube here in this particular. तो पहले हम क्या करेंगे? We'll draw one plane here and we'll take some dimensions. आपको नहीं करना है सॉफ्टवेयर में काम, बस for your imagination I'm showing you. Let us say this is 10 mm and this height is also 10 mm. So we got a plane. तो इसको हम solid में convert करेंगे. This is 10 mm and this is for both the side. Now you can see what this is a cube. Am I right? आप cube को देख सकते हो यहाँ पे?
Yes, sir.
Yes.
Yes, sir.
Yes. So this cube has total 6 faces, and suppose the observer is standing here. Observer यहाँ पे है, तो उसको he want to see this particular face. When it is possible, अगर मैं इसको खाली, if I just show you like suppose a front. Now you can see only one face, right? You can see only one face which is in front of you. Now, what is this condition? This condition is that, suppose right now you are observing this particular plane. It appears as a plane, but मैं इसको थोड़ा सा tilt करता हूँ, and just give me 2 minutes. Yeah. Now you can see here, this is actually what? A plane here. This is a plane. Even if I just rotate, you will get that is also plane. But when I see this front, it appears as a rectangle only. It appears as a, what we can say, a square only. If I just see the front view, it appears as a square only. Now this actually, this line represent this plane, while this line represent this particular plane. Similarly, this line and bottom side also. Okay. Now when this is possible, when this particular surface, ये जो surface है, if this is perpendicular to eyesight, if this is perpendicular to eyesight, ये कैसे आता है? Let us say if I just tilt it slightly, now this becomes perpendicular to our eyesight. In that case, we can see only one surface of an object. एक ही view at a time हम देख सकते हैं. When the condition is that the surface of an object is perpendicular to our eyesight. Eyesight means हमारे जो eyes है उससे जो rays है that is traveling perpendicular to one of the surface, so that we can see only one surface at a time. Now this particular what we can say surface is called as one view. Now as there are total how many surfaces? 6 surfaces are there. We can say there are total 6 views are possible. Am I right? How many views are possible for this particular cube? कितने views possible है? कितने surfaces है? 6 surfaces है. इसका मतलब how many views are possible? 6 views are possible. Right. But when it is possible? When the eyesight is perpendicular to one of the surface. अगर front है, the eyesight must be perpendicular to front. So that means we can see only what we can say 6 faces, 6 surfaces. We can see this is one view, this is another view, this is third view. Okay, when the eyesight is perpendicular to one of the surface. Got it? So we can see when eyesight is perpendicular to this, एक perpendicular है, then and then we can see only one surface. Okay, so when eyesight is perpendicular to one of the surface, perpendicular means orthographic. This particular projection is called as orthographic projection. Now, as 6 views are possible, we can draw the 6 views. The name of the views is like front view, top view, then bottom view, then back view, front, top, bottom, back, and LHS
Left hand side view.
RHS. So there are total 6 views are possible. But to explain, to reveal, to understand any object, we require minimum 3 views. Generally, we are calling as front view, top view, any one view of this LHSV or RHSV. Bottom view and back view generally we are not considering, because if you just say the front view and the back view, both are same. If you just see the top view and the bottom view, both are same. So that's why if I just see any, what we can say solid, if I just say this is a front, uska front and uski jo back side hai wo same hi hai. That's why we can say only one. So we are taking only front, the top, and either LHSV or RHSV. Got it, everyone?
Yes, sir.
Okay. So there are the 6 surfaces, 6 views are possible. But to understand any object, we require minimum 3 views. And now, as we explain here, to project anything, we require compulsorily an observer, an object, and one is the plane of projection. We require these 3 things. This front view, if I want the front view, this is on the plane, and that plane is called as VP, or it is called as a vertical plane. If I want the top view, I need a reference plane, and that reference plane is called as HP. And I need LHSV or RHSV on a reference plane, and that is called as profile plane. So these are the 3 main principal planes: vertical plane, horizontal plane, and profile plane. Suppose you are sitting in a room. तो रूम में आपके आगे जो वॉल है, that is called as a vertical plane. जिस ग्राउंड और जिस फ्लोर के ऊपर आप बैठे हो, that is called as HP. And जो साइड में 2 वॉल्स है, that is called as a profile plane. Suppose you want to show you 3-dimensionally for that. So I can show you. This is a XY plane, or XY, what we can say. This is one plane. This is another plane. So basically this particular space is divided into 4 quadrants. So this plane is called as a VP, this is called as a HP, and we required one more plane that is called as profile plane. This is called as profile plane. Now the location of the particular observer will remain same. The observer will remain here only. Do not change the position. Okay. Now depending upon what we can say, now as this space is divided into 4 quadrants, this is called as first quadrant. This is called as a second quadrant. This is called as a third quadrant, and this is called as a fourth quadrant. Now, depending upon the placement of the object in the respective quadrants, it is known as first angle or second angle or third angle or the fourth angle. Okay, so depending upon whether it is lies in the first quadrant or whether it is lies in the second quadrant or whether it is lies in the third quadrant or whether it lies in the fourth quadrant, depending upon the location or the position of an object, we can call the projection is first angle, second angle, third angle, and fourth angle. Do you know about this? What is first angle projection? Anybody? Anyone? What is first angle projection? We learned in geometrical drawing in the first semester. What is first angle projection? Anyone know what is this first angle projection? पता है किसी को?
Projections in first quadrant.
Yeah. So if I place an object in first quadrant, I'll get certain views, right? Now, जो मैंने अभी ये जो drawing निकाला है, ये जो drawing आपके सामने है, whether it is 2D or 3D, ये 2D है कि 3D है?
3D है.
3D है. But हमारा जो पेपर है, वो 3D है कि 2D है?
2D.
2D. So इसका मतलब we cannot take this 3D directly on the paper. हमको कुछ तो करना पड़ेगा. तो पहले मैं बताता हूँ, if I place an object in first quadrant, if I place an object in the first quadrant, let us say this is a point A. Let us say this is a point A. एक point है. So if I want the front view, क्या करेगा? Observer will look from this direction and he will project that point on this plane. Let us say this is A dash. Am I right? Correct है ये? What is the sequence? We require observer, object, and plane of projections. So observer has to see this particular point and project on the vertical plane. So this particular view is called as front view. Okay. Now we want to maintain the sequence. So observer has to come here, look from the top and project it here. This is called as A and this is the top view. Similarly, with initial position, this is the left-hand side. This is the left-hand side. So observer will come from here and will look from this direction and it will project here. This is called as A double dash. Now we got these 3 views on the 3 different planes, but still it is a, what we can say, it is a 3D. So अगर हमको 2D करना है तो क्या करना पड़ेगा? What I have to do or what we have to do? We have to rotate this particular HP plane. So if I just draw this plane, see this is called as XY line. This is the intersection of vertical plane and horizontal plane, or vertical wall and horizontal wall. So this is called as XY line. This is called as XY line. So if I just draw this particular plane as it is, we can draw it. This is a VP and this point is A double dash, and this is called as front view. Now, if I look from this direction, can I see this HP as a plane or HP as a line right now? आप एक पेपर ले लो हाथ में, उसको हॉरिजॉन्टल रखो एंड देखो, it appears as a line or plane?
Lines.
It appears as a line. So we cannot see the projection of this A on this line. So हमको क्या करना पड़ेगा? We have to rotate this particular plane in clockwise direction. So जब हम इसको clockwise direction में हम इसको rotate करेंगे, तो क्या होगा? We have already the VP is here, vertical plane is here, and after rotating, we'll get one more plane here. So VP यहाँ पे है and I'll get the HP here after rotation. After rotation. So we got the A dash here and we got the top view here. So if I just draw this here, if I just draw this HP here after rotation, or what we can say, unbox this. So we can draw this is the A and this is called as a top view. Got it? Now, similarly, मुझे क्या करना पड़ेगा? We have to rotate this also. We have to rotate this particular, what we can say, this particular side plane, or this is called as a profile plane also. So what will happen? After rotating, it will come somewhere here. So if I just project, I'll get A double dash here. So I can write or I can draw the side view here, and this is called as A double dash. Now, as this we are looking from the left, this particular view is called as LHSV. So this is called as LHSV. So if LHSV is here, so we'll get similarly the RHSV at here. So if I just project it here, I'll get A double dash here, and this is called as RHSV. So I'll get the front view on VP, we'll get the top view on the HP, and we'll get the LHSV on the right profile plane, and we'll get this RHSV on left profile plane. So now we can say this is the 2D. Is this 2D or 3D?
2D, sir.
2D. So we have converted this 3D into 2D system. Okay. So when I place an object in first quadrant, I'll get this system of what we can say projection. So this system is called as first angle projection. This is called as first angle projection. Understood everyone?
Yes, sir.
समझ में आ गया क्या है first angle projection?
Yes, sir.
Now, if I place an object in second quadrant, just imagine, if we place, फिर हम यहाँ पे एक quadrant system draw करेंगे. So we have one more a quadrant system. Okay. Now this is the second quadrant. Observer will remain as it is. Now the point A will be in the second quadrant. Let us say this point A. Now what is difference between these two? The difference is that when I want to draw the first angle projection, we are considering that plane of projection must be transparent or non-transparent in first angle. Should be transparent or non-transparent? First angle के लिए. Okay, suppose I want to see this particular point. Okay, तो ये जो plane है should be transparent or opaque. अगर मुझे point A को देखना है from this observer's point of view,
Transparent.
so it must be transparent. तो क्या करना है? What is the sequence? Observer, cutting plane. ये है observer, cutting plane, and third sequence is object. While in first angle sequence क्या है? Observer, दूसरा है object, and तीसरा है cutting plane. लेकिन यहाँ पे थोड़ा उल्टा है. Observer will remain as it is, but second में आ गया cutting plane or plane of projection, and third one is the object. Now we cannot see this particular object through this plane if it is opaque. So that is possible when the plane is transparent. Okay, फिर हमने क्या किया? We are looking through this plane. We are looking at and we are drawing. This is called as a front view. This is a VP. This is HP. Now to maintain the sequence, we have to project this on this HP. Okay. Now as like this is a 3D representation. मुझे अगर 2D representation करना है तो मुझे क्या करना पड़ेगा? We have to rotate this particular HP in a clockwise direction. तो अगर हम HP को clockwise direction, now here we got A. This is the top view and this is the front view. अगर हम HP को clockwise direction में rotate करेंगे तो क्या होगा? So what I'll do, I'll just draw this front view. This is a VP. So this is A dash. ये front view है. तो अभी क्या करना है? मुझे rotate करना है. तो rotate करेंगे तो क्या होगा? What is your observation? क्या होगा rotate करने के बाद? What happens? What will happen? ये जो top view है, that is A है, will get overlap on this A dash. Am I right?
Yes, sir.
ये इसके ऊपर overlap होगा. And ये अगर overlap होगा, तो कुछ meaningful हमको मिलेगा क्या? If front view and top view gets overlap, मान लो अगर हमारा एक front वाला फोटो है और top view वाला फोटो है, दोनों को overlap किया, तो कुछ meaningful output या information मिलेगा क्या? No, the answer is no. So that's why we are not using the space of second quadrant. We are not using at all. Similarly, if I place an object in fourth quadrant, ये हमारा fourth quadrant है, तो sequence क्या है? Observer, object and cutting plane or plane of projection. तो हमको यहाँ पे मिलेगा front view, let us say A dash, we'll get the top view here, A. फिर वही कहानी, if we just rotate this HP, what will happen? This A or this top view will overlap on this front view. So that's why we are not using the space of second quadrant and fourth quadrant. तो हमारे पास option दो ही बचे, एक है first quadrant and दूसरा है third quadrant. Okay, so that's why when we say the classification of orthographic projection, when we say the classification of orthographic projection, it is classified as first angle and next one is the third angle. We are not using second angle and fourth angle at all. Understood, everyone?
Excuse me, sir.
Yes.
Can you scroll up, sir?
Yes. What is your doubt?
No, sir. I just was taking screenshots and got it.
Don't worry. I will repeat this n number of times when we're going to meet physically for the maybe for the classes. Maybe
So these things that you're teaching on the whiteboard, you will be teaching offline also on the board and all?
Yeah, on the board only.
Okay, sir.
Here I'm using whiteboard and I'm using digital pen. There I'm using chalk and board. That's it. Okay. But to understand the concept of 3D, I'm showing in the software. Correct?
Yes.
Okay. So here, okay. Now, we'll see the details of this particular orthographic projection later on. Now, this particular thing, up to what time our lecture is there?
45.
So 5 minutes more.
Okay. Now, right now you can see this cube, right? Is this a 3D or 2D?
3D.
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 3D, correct. Now, I'll just explain quickly. You can see here, sorry. You can see here one point is there, and from this point, the three edges are originating, right? So if I just draw it like this, it's something like this. Okay. Let us say this angle is alpha, this angle is beta, and this angle is a gamma. What would be the condition? Let us say alpha is equal to, sorry, plus beta plus gamma is equal to how much?
360.
360. 360. Correct. So I'll get a condition 1. If alpha is equal to beta is equal to gamma is equal to how much? 360 divided by 3. So each angle is equal to how much? Each angle is equal to how much?
120.
120. Okay, 120. I'll get condition number 2. If alpha is equal to beta, but it is not equal to gamma. Any two angles are equal, but the addition is 360. And I'll get the condition number 3. If alpha is not equal to beta, but it is not equal to gamma, but the addition is 360. All these three conditions are 3D. So when all angles are equal, this is called as isometric. This is called as isometric. Iso stands for, iso means equal. Iso means equal or same. What is same? Angle is same. All these three angles, when all these three angles are same and we are looking from the corner, this particular projection is called as isometric projection. But condition number 2, if any two angles are equal, this is called as diametric. This is called as diametric. And third one, if none of angle is equal, this is called as trimetric. This is called as trimetric. So we have the three conditions. One is the orthometric, diametric, and trimetric. All three conditions are 3D. But from our syllabus point of view, the isometric is important. Now, the one cube is in front of you, and you can see the three edges originating from this alpha, beta, and gamma, and all, if all are equal, then we can see this particular projection is called as isometric projection. Got it, everyone?
Yes, sir.
Okay. Now we're not going to see in much what is diametric and trimetric. We'll see later. Now in isometric, once I rotate this particular, I will show you how to rotate this. Suppose right now we can see only one surface, one in front of us, so we can see whatever the length, whatever the height of this particular as it is. Now what I'll do, I'll just usko main thoda tilt. I'll just tilt it. I'll just rotate it. Now how many faces visible now? How many faces visible?
Two faces. Two faces.
Now what I'll do, I'll just tilt like this. Now how many faces visible?
Three faces.
Three faces. Now in this case, whatever the length, whatever the angle is true, but when we just tilt it, now ये जो length हमको मिल रहा है, whatever the length here we can see, यहाँ पे जो भी हमको length मिल रही है, वो actual है क्या? ये जो length मिल रही है,
Total length.
ये जो length हम दिख रहे हैं उस face की, वो actual length है क्या face की?
नहीं सर, वो तो
sir.
इनवर्ड रहेगी ना, हम लोग आउटवर्ड देख रहे हैं अभी.
Yes, तो ये नहीं है. Even if I just rotate this, तो हम इसको थोड़ा हम रोटेट कर रहे हैं किसके लिए? आइसोमेट्रिक के लिए. सॉरी, जस्ट अ मिनट. तो can we say that whatever the length, whatever the height, ये जो length है या ये जो height है या जो whatever the depth we are, let us say we are observing from this, it is the actual one?
Yes sir, we can say we are viewing the top view.
नहीं, अभी जो हम यहाँ से देख रहे हैं, तो ये जो हमको दिख रहा है वो एक्चुअल में वही है कि रेड्यूस्ड है?
ओरिजिनल है.
तो ओरिजिनल है.
फिर से देखो.
ओरिजिनल.
तो किस साइड से देखें हम?
फिर से मैं आपको एक्सप्लेन करता हूँ. ये है वन फेस, राइट? तो ये जो फेस लेंथ है अभी जो हमको दिख रहा है वो एक्चुअल है, करेक्ट। ये जो हमको दिख रहा है ये असल में रियल लेंथ है, एम आई राइट?
Yes, sir. Yes.
ये जो हमको दिख रहा है वो एक्चुअल है। ये जो एंगल है 90 डिग्री वो भी असल है, जो हाइट दिख रही है वो भी असल है, लेकिन मैं इसको थोड़ा टिल्ट करता हूँ। मान लो मैंने उसको क्या किया, थोड़ा उसको टिल्ट किया, तो अभी जो हमको ये लेंथ दिख रही है, ये जो लेंथ हमको दिख रही है वो उसकी असल में एक्चुअल लेंथ है क्या?
नहीं, sir.
नहीं है। तो नेक्स्ट कंडीशन में फिर हमको उसको थोड़ा रोटेट करेंगे, तो ये जो हमको लेंथ अभी मिल रही है वो ट्रू है क्या? सॉरी, जस्ट अ मिनट। हाँ, ये जो लेंथ हमको दिख रही है यहाँ पे, ये जो हाइट है, ये जो डेप्थ है, जो हम यहाँ से देख रहे हैं वो असल में एक्चुअल है क्या?
No, sir, it is reduced.
No, sir.
Yeah, definitely it should not be equal to the actual length. It is apparent. क्योंकि असल में जब हम कोई भी क्यूब देखते हैं तो ये एक्चुअल एंगल कितने का होता है? एक्चुअल एंगल कितने का है?
90.
90 डिग्री। लेकिन अभी ये 90 डिग्री है क्या?
No, sir.
नहीं, sir.
It is not 90 degree. If the angle changes from 90 to something different, similarly the length is also going to be changed. So this is a disadvantage of 3D. 3D hai, our human eyes is what we can say very and easily understand the 3D, but it is very difficult to understand the 2D. 2D में क्या होता है? ऑर्थोग्राफिक प्रोजेक्शन में we have a different 3 views here. यहाँ पे 3 अलग अलग views है, उसको कोरिलेट करके 3D को इमेजिन करना ह्यूमन आई को या ह्यूमन ब्रेन को थोड़ा मुश्किल है, इवन स्पेशली फॉर द लेमन्स। वी कैन डू इट प्रैक्टिस, बट 3D को समझना बहुत आसान है। वी कैन अंडरस्टैंड द 3D वेरी इजीली, but the disadvantage here is that whatever the length, whatever the height, whatever the angle we are observing is not actual one, it is different. Okay, it is a different. वो क्यों है, वो कैसा है, वो किस लिए है, वो हम नेक्स्ट सेशन में देखेंगे। Clear everyone?
Yes, sir.
Okay.
Yes.
So what we have, what we can say revised today, one is what is projection. What are the main two type of projection? So what is projection? Projection is nothing but it is simply image of an object on 2D paper. वो चाहे वो 3D हो चाहे वो 2D हो, इसकी image अगर हमने draw की paper पे, that is called as a projection. Projection is of two types. वैसे तो projection बहुत types है, but if you just see from our syllabus point of view, the projection is of two types. One is orthographic projection and third one is the isometric projection. The second one is the isometric projection. Orthographic projection is classified as first angle and third angle, right? Clear everyone?
Yes, sir.
Okay. Now this basic knowledge is very important and which is required for rest of what we can say your life, because drawing has very important role in your whatever what we can say the next career. So we'll see the what is the application of drawing on onboard ship and how it is useful from your career point of view. Got it, everyone?
Yes, sir.
Yes, sir.
Okay. So in the next lecture, again I'll elaborate what is orthographic projection, what is isometric projection, and then we'll go further the sectional orthographic projection, etc. Okay.
Okay, sir.
Again for the next week at the same time, all three divisions should join with the what we can say the credentials of division 1 only. There should not be any doubt. Okay.
Okay, sir.
Okay. Chalo. Thank you.
Thank you, sir.
Yeah.
Jai Hind, sir.
Thank you so much.
Thank you, sir.
Yeah. Thank you. Thanks a lot.